In this video, we're going to be taking a look at exponents, and you need to turn your Go Math book to page 237, get out your math journal and a pencil. Now we're going to take a look at the essential question for 9.1. It says, how do you use exponents to represent numbers? So let's take a look at the Explore activity on page 207. It says, identifying repeated multiplication. A real-world problem may involve repeatedly multiplying a factor by itself. So a scientist observed the hourly growth of bacteria and recorded his observations in a table. So this is an example of a real-world problem where you would need to use exponents. So you can see after 2 hours there are 2 times 2 equals how much bacteria? 2 times 2 equals 4. And then we can see 3. We take 2 times 2 equals 4 plus 2 equals 8. And then 4 hours, 2 times 2 is 4, plus 2 is 8, plus another 2 is 16. So taking a look at what pattern do you see for A, it says what patterns do you see in the total bacteria column? We can see each number is 2 times the previous number. And I want you to copy that down and place it right in that section A for 200 on page 237. Now let's take a look at section B. We see here it says complete each statement. It says at 2 hours the total is equal to the product of 2 2's. At 3 hours the total is equal to the product of how many 2's? Let's see, 1, 2, 3. So 3 2's. Remember, product is a multiplication. And next one, at 4 hours the total is equal to the product of 4 2's. You can see 1, 2, 3, 4. Now let's take a look at the reflect question. It says, how is the time in hours related to the number of times 2 is used as a factor? So we can see the number of hours is the number of times the factor 2 is repeated. So you can see for 1 hour, just repeated 1 time. 2 hours, 2 times 2. 3 hours, 2 times 2 times 2. And 4 hours, 2 times 2 times 2 times 2. So you can see that relationship there in the chart, the answer question number 1 on page 237. Now let's take a look at using exponents so we don't have to write 2 times 2 times 2 times 2 out. There is a way to save some time and a way that you can write this called exponents. So it says using exponents says a number that is formed by repeated multiplication of the same factor is called a power. You can use an exponent and a base to write a power. For example, 7, the third power of 7 means the product of 3 7s. So taking a look at what the third power of 7 would be, the base is the number that is multiplied. So 7 would be the base because we're multiplying 7. And the exponent tells how many times the base appears in the expression. So the third power of 7 means you're multiplying 7 3 times. 7 times 7 times 7. So we can see how to read the power. So 6 squared, we could read 6 squared, 6 to the power of 2, or 6 raised to the second power. For 7 of 3, 7 is a base, 3 is the exponent. You could say 7 cubed because 3 equals cubed. 7 to the power of 3, and 7 raised to the third power, different ways to reading this. Now 9 as a base, 4 is the exponent, 9 to the power of 4, or 9 raised to the fourth power, all different ways of saying this. So let's take a look at example 1. It says use an exponent to write each expression. For A, it says 3 times 3 times 3 times 3 times 3. First of all, you want to find the base of the number that is being multiplied, so the base is 3. Okay, we can obviously see here that 3 is being multiplied. Then find the exponent by counting the number of 3's being multiplied. So since there are 5 3's, the exponent would be 5. Okay, so we could see for this, we could say that it is 3 to the power of 5. 3 is the base to the power of 5 as the exponent. Now let's take a look at letter B. something a little bit different. We have 4/5 times 4/5 times 4/5 times 4/5. The first step, once again, you want to find the base of the number being multiplied. So the base is 4/5. Pretty easy there. Now you want to find the exponent by counting the number of times 4/5 appears in the expression. So the exponent, we can see, since there's 4/5 being multiplied 4 times, it'd be 4/5 to the power of 4. Now there is a parentheses whenever you're dealing with a fraction. And the reason why there's a parentheses whenever you deal with a fraction, that shows that the whole entire fraction is being multiplied that many times. So we know that 4/5 is being multiplied 4 times, as opposed to if I were just to write it 4/5 to the power of 4, I would think that I would multiply just 4 times, but not my 5. When we put a parentheses, the whole entire fraction is being multiplied by what the exponent says. Okay, so let's take a look at the your turn section. It says use exponents to write each expression. We're not solving these yet, we're just writing the expression. So I take a look at my base for number 2, that's 4. And I look at how many times 4 is being multiplied, that's 3, that's going to be my exponent. So I could see that, saying this, I could say it's 4 cubed, or I could say 4 to the power of 3 would be how I would write that. Now let's take a look at number 3. First of all, we're going to find the base, which is 6. How many times is 6 being multiplied? Just one time, or there's just 1 6 there. So it would be 6 to the power of 1. Let's take a look at number 4 together. We have 1/8 times 1/8. First of all, you find the base, which is the number being multiplied. Since this is a fraction, we're putting in parentheses. That's so we know that the whole entire fraction is being multiplied. And now we're going to find the exponent, which is 2, because 1/8 is being multiplied 2 times. So we would have 1/8 to the power of 2. Now we've looked at how to find the exponent, or how to write it out. Now we're going to look at how to solving it, or finding the value of a power. So it says to find the value of a power, remember that the exponent indicates how many times to use the base as a factor. So it says property of 0 as an exponent. It says the value of any non-zero number raised to the power of 0 is always 1. Okay, so for example, 5 to the 0 power is going to equal 1. 15 to the 0 power will always equal 1. 1 billion to the 0 power will always equal 1. Now, we're going to take a look at example number 2. It says find the value of each power. So it says 10 to the power of 4. So you want to think through this. It says identify the base and the exponent. So we know the base is 10, the exponent is 4. So what does that look like? That looks like this: 10 times 10 times 10 times 10. And we can see, multiply 10 by 10 4 times, and we can see it has an answer of 10,000. For example number B, we have 4/10 to the power of 3, and if identify the base, which is always the non-exponent, so 4/10. And then we're going to multiply it by 3 times. Why 3 times? Because the exponent is 3. So 4/10 times 4/10 times 4/10, you can see is 64 thousandths. Now let's take a look at letter C. We have 3/5 to the power of 0. Identify the base, 3/5. The exponent is 0. Remember our rule at the top, the value of any non-zero number raised to the power of 0 is always 1. 3/5 is a non-zero number. In other words, it's not 0. So 3/5 to the power of 0 is going to equal 1. Letter D. We have 2/3 to the power of 2, or 2/3 squared. Identify the base, which is 2/3, and the exponent, which is 2. So we take 2/3 cubed equals 2/3 times 2/3. It's going to give you 4/9 for the answer. Let's take a look at number 6. We'll do this together. Number 6, we have 3 to the power of 4. So that means it will look like this. We want to identify the base, which is 3. Multiply 3 by 4 times. 3 by itself 4 times, I should say. So 3 times 3 times 3. This is what it will look like. So we have 3 times 3 equals 9. 9 times 3 is 27. 27 times 3 gives you a total of 81 for the answer. Now 7 can be a little tricky, but it's not too difficult. We're going to identify the base, which is 1, and the exponent is 9, so you're multiplying 1 times 1 times 1 times 1 times 1. You can see multiplying 1 by itself 9 times, and you can do this from now until next week, and you'll still get 1 as your answer. Now I'd like you to do number 8. You can work on that all by yourself, and you can work on that now. Okay, so you can see number 8, it can be read as 2/5 cubed, or 2/5 to the power of 3. And you can see multiplying 2/5 by 2/5 by 2/5 is going to give you 8 over 125 for your answer. Now I want you to work on number 9, and you can work on that now. Okay, you can see the answer for number 9 is 144. Okay, I'd like you to work on number 2 on page 40, and you can work on that now. Okay, so you can see the answer for number 2. It's 6 cubed, or you could say 6 to the power of 3. Now I want you to take a look at number 4 on page 240, and you can work on that now. Okay, for number 4, we have 3/4 to the power of 5. Remember, whenever you're writing exponents with a fraction, you have to put the parentheses there. Now I want you to work on number 8, and you can work on that now. And you can see the answer for number 8 is 1,000. Now the final one I would like you to do is number 15, and you can work on that now. Now you can see the answer for 15 is 1. Remember the rule, the value of any non-zero number raised to the power of 0 is always going to be 1. Now let's take a look at the essential question. Check-in says, how do you use an exponent to represent a number such as 16? You can use an exponent to write a number that can be written as a product of equal factors. In other words, 16 equals 4 times 4, or 2 times 2 times 2 times 2. So it can be written as 4 squared, or 4 to the power of 2, or 2 to the power of 4. Now this concludes the video on exponents. If you have any questions about this concept, please come and see me.